moving on, and once again, we have, well, our second item also relates to a piece of Commission research, this time commissioned by Qualcomm rather than the Spectrum Policy Forum. And this report is not yet available, but I'm sure is going to be equally of interest in terms of its contents. I'm delighted to welcome back to the Spectrum Policy Forum, Janette Stewart, who's well known to many on here today. Janette from Analysys Mason, I believe you're the one of the report's authors. Look forward to hearing what you have to say. Over to you.
Thank you, David. And just to say, it's great to be here. Thank you very much for the time today. I'm joined by my colleague Chris Nickerson, and what we're going to do in the next sort of 10 or 15 minutes is just run through some very high-level summary of the results of a study that we have just completed on behalf of Luigi and Qualcomm relating to spectrum for 6G. Joe, I'm just checking, are you sharing the slides? Because I cannot see those, or should I share them?
And we do have them. Julia, if you could put the slides up, please. I think I added them to the same deck.
I don't see them in the deck. 1 second, I'll just
maybe just refresh it. I added them whilst the last presentation was occurring. They should be in there.
Okay, 1 second.
I certainly can see them. If you can't find them, I'll share the screen. It's fine. Apologies, Janette and Chris.
No, that's okay. I will maybe just start my introduction while the slides are appearing. So we've conducted this study over the past 4 or 5 months. I'm sure many of you today will be aware that there are discussions starting from vendors in academic research into technologies beyond 5G, 5G advanced, and looking forward to 6G. And so the purpose of this study was to consider at this early stage what spectrum considerations might be related to future mobile use and 6G technologies. So if I go on to the next slide, please. So the purpose was to investigate spectrum bands that might be relevant for further study in the context of future mobile and 6G. Clearly, it's too early to conclude on precise frequency bands, but the purpose of the study was to look at where there is interest in the market in pursuing options in different frequency ranges. We categorized the ranges that we were looking at into 3 categories. This was purely just to aid our research, so there's no sort of technical reason or other logic to why we have separated the bands this way. It was purely just to help our research. We looked into low band spectrum, which we defined as spectrum below 1 gigahertz, starting from around about 380 megahertz. Then we had mid-band spectrum, and we have quite a wide bandwidth of mid-band. We have considered between 1 and 24 gigahertz to be what we would call mid-band. And then we have high-band spectrum, which broadly starts around about the millimeter wave spectrum already identified for 5G use at 26 gigahertz, and then goes all the way up into sort of the new frontier of opening up of sub-terahertz and terahertz. So in the presentation, you will see that our results are categorized in those 3 buckets of low band, mid band, and high band. Just in terms of how we approached the study, we used a combination of inputs. We undertook our own research of published material. There's a lot of material in the public domain already, white papers from universities, from industry bodies, from collaborative 6G research programs, from equipment vendors describing early stage technology concepts, propagation effects, use cases for next generation wireless. So we did a review of that overall material just to identify some of the factors that might influence spectrum. Importantly, we also conducted a number of primary research interviews, and this was to gather expert views from across industry, from regulators, and from the academic community. So there are several people on the attendance list today who I think we spoke to during the study, so thank you very much for your inputs. The study did have a global focus, but also looking at regional variations. So please just bear in mind when we go through the presentations that this is not UK specific. We were asked to look globally, but also at where there might be regional differences, but we didn't get down to the detail of specific sort of UK implementations, if you like. So if we go on to the next slide, please. One thing just to put into context in terms of the options is that there are already a number of frequency bands that are under consideration currently in the context of the next World Radio Communications Conference, and also potentially in the pipeline for consideration at the WRC beyond that in 2027. Now, some of those frequency bands which might be considered in relation to possible future mobile use or identification for IMT, just given the timescales involved in perhaps making those bands available for 5G, changing the use, etc. Some of these bands might actually turn out to be early frequency band candidates for 6G. So shown on the slide here is some of the bands which are actively under consideration currently, and so it's probably no surprise when we go through the findings that you will see that these bands do feature in the feedback we received in terms of promising future bands. If we go on to the next slide, please. So starting with the low bands, so this was below 1 gigahertz. I would just say before we go into the detail here, when we did our primary research, we asked some very open-ended questions. So our objective really was to hear from the interviewees what their expert view was. So when we talked about bands below 1 gigahertz, we talked broadly about that frequency range. So we didn't sort of preempt the discussion, if you like, by suggesting bands. We tried as far as possible to go through the spectrum sort of logically and sequentially and ask the interviewees to tell us what they thought. So in the low bands, generally the most promising new band option for mobile use in the future was broadly identified as being 600 megahertz. And the 600 megahertz band obviously is in people's minds for a number of reasons. It is being discussed actively already in the context of preparations for the World Radio Communications Conference in 2023. There could be various reasons for interest in this 600 mobile allocation specifically. So in some regions, in some countries elsewhere, US and Canada, for example, this band has already had a change of use into mobile and has already been assigned for commercial mobile use. So there is a 3GPP band N71, which may be focusing people's attention, given that there is a growing ecosystem here. So the 600 megahertz band, which is approximately 617 up to 698, was certainly one band where we found there was consistent interest from interviewees in considering a change of use for mobile and possibility for future mobile technologies. The other frequency bands that were identified were 380 to 400 megahertz and 410 to 430 megahertz. And obviously, many of you here today will be aware that those frequency bands are not part of public mobile spectrum deployment. Typically, these are used typically for land mobile systems, and in the UK supports important emergency service communication, as well as various other important uses. So the intention of I think interviewees when identifying these bands as being of interest for future mobile technologies was not to say that these bands would change their use in any way, but simply to think that existing systems within those bands might evolve, and there is interest in future mobile technologies with better capabilities being designed to operate within those bands. I think the other important thing just to mention in the sub 1 gigahertz range is there are already several bands used in public mobile networks in the UK and elsewhere, so 700 megahertz, 800 megahertz, 900 megahertz, etc. There was general support, I think, from probably all of the interviewees that we spoke to, which was that 6G technologies should natively support those existing mobile bands. So there is an assumption that in the same way as previous generations of mobile technology have evolved into 4G and 5G, that same evolution will be relevant moving into 6G. So that's a summary on the low bands. If we could go on to the next slide, please. So we've got several bands here in the mid-band range. First slide here, just looking at 1 to 3 gigahertz. What we found broadly is that any new mobile band options seem to be very limited, if not non-existent, in many markets. And there's obviously a key reason for that, which is a lot of the spectrum in that frequency range is already used for mobile networks. So there is, as I mentioned, in relation to the low bands, there is an assumption that 6G technology will natively operate within these existing bands, which are already allocated to mobile and identified for IMT. However, there may be opportunities to expand the spectrum available in this range within specific countries. So I would say this is not really specifically related to the UK, but at least one of the interviewees that we spoke to who focuses on the US market just indicated that some of the bands allocated in the US to federal agencies in the 1 to 3 gigahertz range might be considered for a change of use at some point over the next decade. And so the bands identified are 1300 to 1350 megahertz, 1780 to 1830, and parts of 1960 to 1164 megahertz. If we then move on to the next slide, please. So looking into the sort of core of the mid bands, if you like, in the 3 to 9 gigahertz range, I think it's fair to say that it's within this range that probably we saw or we heard the most commercial interest in having additional mobile spectrum. And the reason probably for that is to build on the foundations of 5G in the C-band and to be able to expand existing use cases that are already emerging with 5G in a similar frequency range, assuming that networks would have similar architectures and use similar bandwidth channels to what we're starting to see in 5G. One point, obviously, that it probably goes without saying is that these bands are very heavily used by existing services, by fixed links, by satellite, various other important applications. So it's by no means clear if or how additional spectrum could be made available for mobile in these bands. Notwithstanding that, though, the interviewees that we spoke to identified several ranges of bands where they think further study could be done. So one of those is 3.3 to 4.2, and I think there's already study ongoing into that range, so I don't think I need to say more on that. That range is already widely available in the UK, both within public mobile networks and through Ofcom's shared access licensing in 3.8 to 4.2. That's not the case in other markets, so perhaps that band, making that more widely available is more relevant in other markets that we consider rather than the UK. 4.4 to 4.99 gigahertz was also a band that was identified by several of the interviewees as being potentially interesting for further examination. There is already licensed mobile use in other markets in parts of this range, and so there is a developing ecosystem there. Upper 6 gigahertz, I'm sure many of you are aware of that this 6 gigahertz topic is one of the key topics perhaps in the lead up to WRC 2023. In a few markets already, the entire 6 gigahertz band has been made available on an unlicensed basis for the next generation of Wi-Fi technology. However, within Region 1, the upper 6 gigahertz portion is under study within 6425 to 7125 gigahertz. Within the interviews that we conducted within this project, there was interest expressed and demand in having additional spectrum around about this range for licensed IMT use. And then finally, 7 to 8 gigahertz, I think, is probably a similar story to the upper 6 gigahertz in that some interviewees identified that as a possible band of interest in terms of expanding the availability of mid-band spectrum for mobile use. So if I then go on to the next slide, And this is just the final slide in relation to the findings on the mid bands. We also found various interviewees identifying portions of 10 gigahertz, 12 gigahertz, and 15 gigahertz as being of interest for consideration for future mobile and 6G technology use. Sort of above 15 gigahertz, there was no interest identified between 15 and 24 gigahertz, and I think probably that reflects the fact that existing use in that portion is intense anyway, and there is already, of course, just above 24 gigahertz, there is the 26 gigahertz band, which is already identified for 5G. Some of the bands that I'm showing on the slide here, 12 gigahertz, 10 and 15, were identified by some of the interviewees that we spoke to in other markets. So again, just I suppose a health warning here that this feedback does not necessarily relate to views expressed in the UK. If we then go on, please, to the next slide. Many interviews commented that obviously WRC 19 was successful in identifying several bands in the millimeter wave range for 5G use. It is still early days for these bands being deployed. The 26 gigahertz is the most advanced in terms of harmonization, certainly in Europe. There was an assumption that future mobile technologies in 6G, again, similar to the mid and the low bands, that 6G should natively support these millimeter wave bands to allow evolution of 5G systems into these bands. The bands that were most commonly identified through our research were 26 gigahertz itself. Some comment around future mobile technologies in 28 gigahertz. Then there's 37 to 43.5 gigahertz. And just noting that band is actively under consideration in other markets anyway for assignment for mobile use sort of in the short term. Then there's 45.5 to 47 gigahertz, 47.2 to 48.2, and then also 57 to 71 might be of interest from the perspective of 6G technologies being supporting that band. It was also noted as well that some of the other bands that were discussed at WRC 19, such as the E-band spectrum 71 to 76 and 81 to 86 might also be reconsidered as use cases evolve for future mobile use. So if we then move on, please, to the next slide. So moving in then to the sub-terahertz and the terahertz range, I think it's important to acknowledge that commercial interest in these very high frequency ranges will be limited until there is more clarity over technology feasibility and use cases. So that was broadly what we found, was that commercial interest in sub-terahertz and terahertz is somewhat muted currently until there is a better understanding of the use cases and the technologies and the architectures. However, there is acknowledgement that there is significant amounts of academic research underway. Various vendors are looking into future technologies and use cases in these frequency ranges. There was a number of obviously interesting new use cases that came up through our research, and I'm sure many on the call here will be aware, things like wireless cognition, imaging, both fixed and mobile communications, high precision positioning, etc. So some very interesting use cases which are not just building on 5G use cases, but are perhaps sort of entirely new use cases. Some interviewees felt that some of these use cases are not necessarily mobile type services, they're more sort of limited mobility. The sorts of architectures that are under research range from sort of small cells to short range in buildings, and also cell-less infrastructure where the device attaches to the RAN rather than to a single cell. So there's a lot of research ongoing. Certain bands in the sub-terahertz range are currently protected due to passive satellite allocations. So although it seems as if the bandwidth is ample in these frequency ranges, if you take into account protecting existing passive allocations, then that does put a limitation on the amount of contiguous spectrum that might be available. And I guess that is a key point for the industry to consider is how much bandwidth is needed and how much contiguous bandwidth, because if the passive satellite bands are to be protected as they are currently specified in footnote 5.340, then that does limit the choices. Just a final point I think to make is that obviously we're fortunate in the UK that Ofcom has already taken steps to sort of incentivise experimental and use of these high bands, as have regulators in the FCC in the US and in Japan. The bands that have been made available in the UK and the US and Japan are shown on the slides there. So there is obviously some commonality between the bands identified in the different markets, although some differences as well. So that is a very quick summary. I think that is the end of my presentation. So I'm going to stop there and just thank you for your time and ask for any questions.
Janette, I'm just going to step in because I'm sure there will be some questions on that. It's really nice to see, in fact, to see both of you again, and really good to see some spectrum being identified, at least for discussion around where it might go on 6G. It's going to be, and in fact, this might well contribute to one of our workshops later in the year, looking at not WRC 23, but the next one in terms of agenda items and what have you. I'm just looking to see if there are any hands going up or questions on there. It may well be that actually people are going to want to digest this. Do we have an idea yet when the report is likely to be issued?
Well, I'll need to defer to Luigi. I think there's no decision yet on whether the full report will be published, but these slides certainly can be made available to the SPF participants, and I will speak to Luigi about whether there's a possibility of, for example, a summary version being made available to everybody.
Yeah, for Janette, for the slides, they will be available for the SPF members, and then let's discuss for the report if we could also make it available.
Luigi, thank you very much indeed, and Janette, thank you. And you have a question, I think, from Stephen Talbot.
Hello, Janette.
Hi, Stephen.
Yeah, I was just interested. So there seemed to be a lot of interest in, say, spectrum bands below 10 gigahertz, and I must admit I'm not close to the very early discussions on 6G. But is that an indicator that 6G is going to be very much able to utilize smaller bandwidths, which you would think would be more prevalent in bands below 10 gigs, whereas as you move further up the spectrum bands, the possibility for larger bandwidths is greater just because of the mathematics involved. So is that an indication of where the thinking is on that 6G needs to be, whereas 4G might have been, I don't know, sub 5 gigahertz, 5G was going to be above 10 gigahertz, whereas 6G as a technology is very much focused upon utilizing any bandwidth types from the traditional low frequency bands right up to higher frequency bands. Or am I misinterpreting the report?
So that's a very good question, Stephen. I think the answer to that is not clear yet, because the technology that will provide the foundations of 6G is not yet defined. I think what is interesting from the research, though, is that there was, if you like, demand from the industry that, or they saw demand for 6G to continue to support existing mobile bands as well as having some new bands. So that does suggest that 6G would evolve in the same way as 5G has done, that there is a mixture of low and mid bands that use smaller channels and then high bands that use the wider channels. obviously in the 3GPP specifications for 5G, you've got the difference between the FR1 and the FR2 bands, that FR1 is typically 100 megahertz, and I would imagine that if we're thinking about spectrum in the sort of 6 to 10 gigahertz range, then probably we're talking about multiples of 100 megahertz again. But if you're going into the high bands, obviously then much higher or much larger bandwidths might be envisaged. Some of the academic research is looking at, I think, 5 or 10 gigahertz per network. So that would be 20 gigahertz contiguous if you had 4 operators, say. So I mean, and this is thinking about the academic research in the sub-terahertz range in particular. So I think the answer is that there seems to be thinking along the lines that there will be different bandwidth requirements in different ranges as there are in current mobile allocations and uses currently. But of course, some of the new use cases that are being envisaged for 6G that I know you've talked about in the SPF and other contexts, some of those new use cases actually might merit having very wide bands, and that obviously might not be suitable for existing low and mid bands, but might have to go into very high bands where there's more bandwidth available.
Okay, thank you very much. Just as a postscript, I was just going to note that the discussion about 5.340 bands, where passive use is quite often there to monitor climate change, is equally, as we've just heard in the previous discussion, equally very important. And that debate can't be, I'm sure you weren't, can't be glossed over, of the importance of 5.340 bands. Thanks, Janette. Nice to see you.
And Janette, you have a question on the chat. I don't know whether you've already seen it. There's a comment by Kern Miele. I hope I pronounced that right. But there's then a question immediately below it. Do you have that one?
Yes. So the question is, how much interest from Ofcom or other players is there in spectrum sharing for 6G? And the answer is there was a fair bit of interest in progressing technologies that are able to share spectrum together, both together with each other and together with existing use. So there is some interesting academic research in the UK and elsewhere, in fact, that's looking at mid-band spectrum sharing scenarios between fixed and mobile services. There was also, I think, a lot of feedback from regulators that the process of changing use from one service to another can be time consuming, can be costly, and that designing mobile technologies from the outset to be polite and able to share is actually going to be a key benefit in future. So the answer is yes, there was quite broad interest in pursuing that kind of study.
That's great. Janette, thanks very much indeed. Interesting study. Really good to have those, the findings out there. We'll be coming back to this without question in future. So thank you very much indeed to you and to Chris for your work on the report. We'll look forward to, I'm sure the slides will be downloaded and absorbed, and I'm sure we'll see you on this again before too long. But meantime, thank you very much indeed to both of you.